Okay, given f of x equals this polynomial, sketch f of x, and then indicate on the graph local extrema, extrema being maximum or minimum points, and points of inflection. Okay, so how do we find the local extrema? Well, local extrema are the local maximum or minimum. How do I find those? Remember that I have to use the derivative. The first derivative tells me the local maximum or minimum. Okay, so that's going to be done with the help of f prime of x. The points of inflection, well, in order to find the points of inflection, I have to either use f prime of x or, well, in conjunction really with f double prime of x, right? So I'm going to be using these two tools to help me. And then I'll probably need to find the x-intercept and the y-intercept to help me with the graphing. Okay. All right. So let's start with finding f prime of x. F prime of x, if I derive this, that becomes 12x cubed minus 48x squared plus 48x. Okay. And now I can probably factor this. I have an x in each term. I have 12 in each term. So I can factor this. Let's pull out a 12x there. And so I end up with x squared minus 4x. Okay, and from here plus 4. Okay. This now can further be factored into, well, that just looks like an x minus 2 squared, doesn't it? So that's x minus 2 squared. So there's my factored form. Now I can find the zeros of my derivative function, which tell me the locations of either a maximum, minimum, or a point of inflection, stationary point of inflection. So where is f of prime equal to 0? Oops, sorry, f of x is equal to 0 at x is equal to 0, right, for that one, and also at x is equal to 2. Okay, so let's draw the sign diagram of this and figure out what that's going to look like. The sign diagram of f prime of x, oops, is going to be a, sorry, that's not very neat, but is going to be, well, I have my critical points here, 0 and 2, and then I need to find the intervals. What is the sign of each interval here? Well, if I put a negative number in here, that's going to end up being negative. If I put a 1 in here, that'll be 1, 1. That'll be positive, so that becomes positive. And here, if I put a 3, that's positive. That's also positive, and so that ends up being positive as well. So this is the local minimum, right? That ends up being a local minimum. Why? Because I'm decreasing, then I'm increasing. Okay, so this is a local minimum on f of x. This, because there's no change in the intervals, or sorry, no change as in the whether it's increasing or decreasing as I move across this point. It's increasing and then it's increasing, so it's going to be a point of inflection. And the one that we've talked about so far has been this is a stationary point of inflection, stationary inflection point. All right. And now I can figure out what the actual, to help me with the sketching part, I'm going to figure out what the actual y value is here. So I'm going to plug that back into f of x. If I put 0 into f of x, I get 0, 0, 0, and minus 9. So f of 0 is minus 9. And f of 2 is, if I put 2, 2, 2, you can do this on your calculator, you will get 7. Okay? So my 2 points are 0, 9, sorry, 0, negative 9, and 2, 7. And this is a local minimum. Okay? And this point is a stationary inflection point. All right? Now, I've only found the one extrema and one point of inflection. Okay? But I still need to test to see if there are other stationary or points of inflection. How do I do that? I need to find the second derivative. Okay, so what is f double prime of x? That should be 2 dashes there. Well, f double prime of x, if I derive this, okay, this will end up being 36x squared minus 48 times 2, which is 96x, plus 48. Okay, and now I can again factor out a 12, and if I factor out a 12 from each of these terms, I get 3x squared minus 8x plus 4. Okay, and then this I can further factor into 12 times 3x minus 2 and x minus 2. Okay, now what happens here is, again, I'm going to be finding the zeros of this because I want to find a sign diagram, right? I want to draw the sign diagram of f double prime of x, because with the sign diagram, then I can figure out if there are any additional points of inflection. Okay, remember we said that there's a point of inflection when f double prime is 0, and also when we have a change in concavity. Okay, so let's figure out what the points are, or sorry, the zeros of this are. This is equal to 0 when, okay, therefore I guess you could say therefore f double prime of 0, or f double prime of x equals 0. Okay, sorry, let me just erase that. Okay, let's just solve this. Let's just solve this here. Okay, the zeros then become, zeros are at, oh, it's really fat. Zeros are at 2/3. Okay, x equals 2/3 and x equals 2. Right, so x equals 2/3 and x equals 2. And so if I put that on my sign diagram, I get 2/3 here and 2 here. And now we just test this again, right? If I put a 0 in, okay, if I put 0 in here, I would end up with a positive number. If I put a, for instance, 1 in, because that number is between here and here, I would get a negative output. If I put 1 in here, or 1 in here, I would get, this would be positive, this would be negative. If I put 1 more here, I would get positive. And that makes sense because this we already know is going to be a stationary inflection point by looking at the first derivative. Okay, so we have confirmed, because this is a 0 of f double prime, okay, and because there's a change in concavity, that this is a stationary inflection point. And this one actually is a non-stationary inflection point. And we know that simply because this is a 0 and there also is a change in sign, but it doesn't show up as a maximum or minimum on my first derivative. Okay, so these are the points that I'm going to now use to graph this. Okay, all right. So what is f of 2/3? Well, remember, to help me with the actual graph of f, I need to put f of 2/3 in, because that's my point of inflection here. So this would be 2/3, and that would end up being, if you do this on your calculator, you end up with negative 2.48. And f of 2 we don't need to find because we already found it up here, right? F of 2 we know is a stationary inflection point. So then I have the point 2/3, and negative 2.48 is my non-stationary inflection point. All right, very good. Now that I have my points, let's go ahead and try to graph this. Okay, let's graph this down here. All right. We know that the points were 0, 9, 0 minus 9, 2, 7, and we had 2/3 and minus 2.48. Okay, so this is just a quick sketch. It's not going to be drawn to scale. We know this is our local min. All right, so we have down here that at 0, negative 9, we would have a minimum. So I would have to have something that looks like this. At 2, I would have something at, sorry, let's make this a little bit bigger. Let's go 1, let's make this 2 over here, just so that it's easier to see. And this would be 1, Let's make that point right there about 2/3. Okay. At 2, I would say maybe that would be about a 2. That looks about right. That's about. Let's just say that's 7. Okay. This is a point of inflection. Okay, and this was what type of point of inflection? It was a stationary inflection point. So since we know that it was increasing, it's increasing and increasing, right? We know that it's going to be increasing like this, probably, and increasing like that, okay? Coming from the left side. At 2/3, I have a negative 2.48. Okay, let's just estimate that that would be about negative 2.48. And we know that that is a non-stationary point of inflection, right? Non-stationary inflection point. And what that means is, well, I'm going to have a change in concavity, all right? Remember that the reason I chose this to look like this is because here this is concave up and here it's concave down, okay? So that's how I know from this graph, okay, what the concavity is going to look like. And here we said that this was positive, so it's going to be concave concave up on this side and concave down on this side, okay? So it's got to be, there's a point of inflection here, so probably this is going to look something like that, and this is going to look something like that, okay? All right, so that's not a very good graph, but if I were to clean it up, it would probably look something like that, okay? All right, where that is the point of inflection, that's one point of inflection, and that's one minimum. So that would be a more accurate graph, okay?